Welcome to the Chapter 3, Section 1, Programming Putting the Pieces Together, Built-in Functions and Expressions Presentation Lecture. Okay, so as we start Chapter 3 here, we are going to start getting into some more complex processes when it comes to programming. We'll be doing some putting in some analyzing of functions as well as different expressions. When you're putting all this together, what you have to realize as a programmer is that a major part of learning how to program is figuring out how to put the different puzzle pieces together that's going to compose that program so the program runs exactly and executes how you want it to execute. The analogy would be taking like a jigsaw puzzle, throwing all the pieces out on the table and then putting them together. Now the purpose of this session is to be able to allow you to define fundamental pieces of a program and demonstrate how those pieces can fit together. There are four fundamental pieces when it comes to constructing a program. There is the instruction, there is the control structure, which we talked about a little bit in Chapter 2, then there's the function and the expression, which we will be talking about here in Chapter 3. The instruction element is a statement that's going to execute. This is carried out by the computer at runtime. Now, if we're going to be using something like object-oriented programming, then we will be using methods. And that's what we're doing here in Alice is we're using methods as we manipulate objects. Now, back in the last chapter, we were able to use methods and instructions to make the objects perform certain actions. So, for example, you take an object like the snowman, turn to face a snow woman, or spider robot, move up half meter. Now we've also used in Chapter 2's in-class example and your labs, you use control structures. Control structures are do in order or do together are the two that we used in Chapter 2 examples and Chapter 2 lab. In Chapter 3 we'll be using other control structures, and you'll see what those are as we start using like functions and expressions. Okay, so let's take a look at functions first. A function simply asks a question, or it checks a specific condition. So if x is greater than 3, if that's true, do this. If that's false, do something else. Now in Alice, a function can be used to get the information that we need about a bunch of different elements within our program. The properties of an object. First of all, is the snowman's face red? Is that true or is that false? The relationship of one object to another. What is the distance between the mummy and the pyramid? Asking a question, trying to get an answer. A current condition might be what key on the keyboard was pressed. These are all different ways of using functions to get the program to execute the way that we want. Now that might get your head spinning a little bit trying to grasp exactly what's going on here. So let's take a look at an example. If we take a look at the first encounter world, which is the one that we started off working with in Chapter 2, the camera angle is going to influence our perception of the scene. Do we really know how many meters the robot might need to walk to reach the rocks where the alien is hiding? Probably not. It would probably be a trial and error or a guesstimation. So how do we solve that problem? We are going to use what's known as a built-in function. We are going to use categories like proximity, size, spatial relation, point of view, and also others. The example in the book here that we have on this slide is we take a look at the mummy. We will go into the mummy's details. We would click on the questions tab, and now we can use a bunch of different built-in functions to properly move our character in the world. So is the mummy within the threshold of an object? Mummy is at least threshold away from, but the one that we really want to use is mummy distance to, and then we can specify another object that we already have placed in the world. Now, in order to do this, we need values. Values are numbers. When a function is used to ask a question or perform a computation, an answer is then returned. What answer is returned is a value. This is the type of value is going to depend on the kind of function. In the example that we just looked at, we want to ask the question, what is the distance of the robot to the rock? What is that distance? And if we don't know, how do we figure it out, or how do we ask the computer program to figure it out? We expect to get a number value in return. It could be a whole number or a fraction value, such as maybe 3 meters or 1.2 meters, or any other number of that matter. take a look and see exactly how this looks within an Alice world, we're going to take a look here at the first encounter distance function demo problem. This is going to make sense to you, or at least it should, because it's going to build off of the in-class example that we did in chapter 2. So let me bring that up real quick. Okay, so this is it right here. This is the world. Now let's take a look here. This is the code that we would have written. This is the code that we would have written. Oh, what's going on here? I think my screen is starting to act up. Let me go back to the lecture real quick. All right, I'm going to go back to that in just a second and see if it comes up clearer. But the built-in distance function is the one that we're going to use, and the function is not a standalone instruction. It has to be nested within another instruction. So let's go back to the example and see exactly what that looks like. Okay, so here is the code. Take a look at this code. And this is what we ran. This is the code that we had created. This is what we did in the in-class example. I can prove that by playing the world. Robot spins. Robot moves over. Okay, so now what's the issue here with this program? The issue with this program is obviously the spider robot cannot move through a rock. So we are going to use a function to fix that problem. And the error of the code is in the spider robot's movement. So we have right here this line of code: spider robot move forward, spider robot distance to rock, duration of 1 second. Now obviously that's not working the way that we want it to work. So there's going to have to be some debugging that's going to take place. How do we fix that? Okay, let's go back. Okay, so now when it comes to the different values that can be returned, we have a Boolean value, which is a true/false value. We have a string value, which is a string of text. We have an object value, which could be a snowman or a helicopter that's in the world. And then we could also have coordinates, or the position of that object within the world. All right, so the problem that we have is that when the program is run, the robot collides with the rock. That can't happen. We need to fix that. The problem is the distance between the two objects measured from center to center. One way to avoid this is to subtract a small number, say 1 or 2, from the distance. We could do that. That's one possible solution. We can also do this by including an expression. Now, an expression is a math or logic operation on numbers or other types of values. Atlas will allow us to do this with different math operators for common math expressions such as addition, subtraction, multiplication, and division. So let's take a look at the first encounter world expression example and see what that looks like. All right, so if I go and open, let's open, here's the expression world. All right, so if I scroll down, you can see the code right here. Spider robot move forward, and then in the expression, spider robot distance to the rock -2 for a duration of 1 second. Let's see how that fixed the code execution. Better, but not the best. We still have the rock and the spider robot colliding, so we're not quite where we need to be yet. Get back to where we were. Okay. Well, now we have another issue. So the best thing to do is, if we take version 2, we're going to subtract 2 meters from the distance in an arbitrary amount. Now, to be more precise, what we could do is we could also subtract the width of the rock. The resulting expression is going to subtract the value from the value of another function. So let's take a look at that example. Bring up version 2. Okay, so version 2, here's the code right here. So spider robot move forward, spider robot distance to the rock minus the rock's width for a duration of 1 second. Let's see if we fix the problem. And now that looks much, much better. The spider robot is not colliding with the rock. And we did that by utilizing functions and expressions. All right, so now at the end of chapter 3, we will go through an in-class example to practice this, and then you will also be assigned reading of chapter 3, which you should have already done, watching the presentation lecture, which is what you're doing right now, and then also functions and expressions. That'll be followed up by the chapter 1 or the chapter 3 lab. There's 2 labs that go along with chapter 3, one based off of lecture 1 and one based off of lecture 2, which you'll be assigned later on. Okay, so that concludes the presentation lecture for chapter 3, lecture 1. Feel free to review the slides and make sure that you have all the information, and I will see you in class tomorrow.